Well, hello, and welcome back. Our topic today and for the next few days is going to be volume of revolution. And today specifically, we're going to focus on what's called the disk method. There's several different methods that we'll learn, and today, like I said, we'll focus on the disk. So before we dive right in, let's go ahead and sketch this picture off to the side here of our function f of x. And before we talk about volume, we're going to quickly review area. And we always said we're going to draw in a rectangle. So go ahead and sketch it, and I'm going to make it a little thick here. Go ahead and sketch in your rectangle underneath the curve f of x. So just to recall, the height of this function we always said is upper minus lower. So in this case, my upper is f of x and my lower is 0. So my height is truly f of x. And the width of this rectangle is the change in x, also known as dx. So if I wanted to find the area under this curve here, obviously this is just one rectangle in, I would sketch an infinite amount of rectangles in here and add them all up to find the area. So our goal here with volume is to take this curve that we have f of x and we're going to revolve it around something. And for this example, we're going to specifically say the x-axis. So I'm going to make a little note here. I'm going to take that curve and revolve it around the x-axis. Now, you kind of need to picture this curve coming out at you. Okay, so here it is. Like I said, and I'll try to have more of a 3D example in class for you tomorrow, but picture this curve literally coming out at you. It's going to come around, it's going to come down, and back around, and you should get something like this. Now the end is going to look rather ovally. Okay, so again, hopefully you can visualize you're taking this curve here, and you're just swinging it out at you, around, and back up to the top. Alright, now I'm going to do the same thing with this rectangle that I've sketched here. Okay, so picture, I'm going to start with this end of the rectangle. Picture it coming down, out at you, out of the screen and at you, and coming around and back up. And I'm going to do the same thing with the other end of the rectangle. You can picture all of this coming at you, around, and back up. And again, this is a rough sketch. I'll try to have a better visual for you in class. And basically, this is the thickness of that piece, that 3D piece that just came out. Okay, now, it's similar, it's, a very small right circular cylinder. So I can easily find the volume of that solid. So because this is a right circular cylinder, I can easily calculate the volume of this purple cylinder that I drew. So I'm going to say the volume of a cylinder is basically its base times its height. Okay, so if I look at the shape of the base of this, well, clearly the base is just a circle, so that's pi r squared. And the height is this distance here, so again, I'm kind of picturing this on its side. This is the base, the height is this distance, which is my dh. Now, taking a closer look, you'll notice that the r in my function is this radius here is really f of x. So I'm going to say that volume is equal to pi times f of x squared dx. Okay, now again, that's just going to give me the volume of one cylinder. To find the volume of the whole shape, I would do the same thing. I would draw in another rectangle. Okay, I would revolve that one around. And again, I'll try to show my side there. And then I'd stick another one in. And we revolve that one around, and yet another one, and another one, and another one, and add those all up. So in theory, when I'm saying add them all up, I'm saying integrate pi r squared dx from a to b. Alright, so maybe you need to think about that for a minute. I'm basically taking the area of a circle, pi r squared, and integrating it, or the cylinder I should say, to find the volume of this shape here. Alright, so a couple absolutes. Oops. Alright, we must do this. First, you need to sketch a rectangle perpendicular to the axis of rotation. Okay, now they're going to switch up that axis on you quite a bit. It's not always going to be the x-axis. It could be the y-axis. It could be any random line that they ask. So first and foremost, you are drawing a rectangular perpendicular to the axis of rotation. The second thing you need to say to yourself is your slice, and that's the word we're going to use for our rectangle, is always the radius. Okay, so your slice, which again is the rectangle, is going to be equal to the radius. So to find volume, you are just saying integrate pi r squared, which in fact is just area of a circle. All right, so let's dive into our first example. Y equals the square root of x. We're going to revolve it around the x-axis from 0 to 10. Okay, so it's going to look very similar to that picture I just drew. So let's go ahead and sketch it out. Here's radical x, and I'm just going to say this is my 10. All right, when they say revolve around something, you are always going to put a nice little arrow to remind yourself what you're revolving around. So I'm revolving around the x-axis, so go ahead and sketch that in. That means your slice is perpendicular to the x-axis. So I'm going to draw one slice in, perpendicular to the x-axis. Again, always check to make sure this is going to be always on the top, and this will always be on the bottom. And the next thing I want you to do is to label this is your radius. Okay, and to get the radius, just like we said in area, you are saying upper minus lower. All right, so every time I say to myself, volume equals the integral of pi r squared. That's what I want to see on all your quizzes, etc. Volume is the integral of area of a circle. Volume equals the integral of pi r squared. Next, you're going to pull out your constant of pi, and I'm going to quickly check my bounds. We said we're integrating from 0 to 10. And I need the radius, and that is that line you drew in. And all you're going to say again is upper minus lower. So radical x minus 0, but this time it's squared. Okay? So again, unlike volume, or unlike area, we need to square that term. And now it's pretty straightforward. Now we just go ahead and do the math. Once you got this set up, you're in great shape. So I'm going to say volume equals pi, the integral from 0 to 10. Oops. Radical x minus 0, of course, is just radical x. And if I square radical x, I just get x. So I'm going to integrate. I'm going to leave my pi out front. The integral of x is x squared over 2 from 0 to 10. Quickly plug in my upper minus lower. Again, I'm going to keep my pi out front. That's 100 over 2 minus 0. So I get a final answer of 50 pi. Now notice, they don't tell you there's any units, so don't worry about that. Unlike the tabular data that we did before, we're just going to strictly integrate and get our answer. All right, probably question 2. Y equals 2x squared, y equals 0, and x equals 2. Revolve that around the x-axis. Okay, so again, you have to sketch. That's going to be one of our absolutes. 2x squared is just a parabola opening upward. And I'm going from the x-axis. So I'm just going to use some colors. The x-axis, y equals 0, x equals 2. And I'm revolving around this x-axis. So again, that's telling me where to draw my curve. It's telling me which way I should put my slice. I am perpendicular to the x-axis, so it's a vertical slice. Okay, and remember this represents your radius. Put a nice little R there. Okay, that is your radius. So to find the volume, remember it's just the integral of area of a circle. Integral of pi r squared. All right, so I'm going to pull out my pi. My radius is upper minus lower. So that's 2x squared minus 0. I'm not going to say minus 0. Hopefully we all understand that's minus 0. It's that quantity squared dx. And now I need to get my bounds, starting at 0, going till 2, since this is the line x equals 2. I'm going to clean it up one more time before I actually integrate, and talk nice and slow to yourself. I have to square that term, so just square everybody you see. 2 should become a 4, power to a power is x to the 4th dx. And then a nice quick integral. I should leave my pi out front, 4x to the 5th over 5 from 0 to 2. Again, I'm going to leave that pi out front. Upper minus lower. 2 to the 5th is 32, so 4/5 times 32 minus, plug a 0 in, I get 0. So that looks like 128 over 5 times pi. And that pi should be on top, of course. And you've got your nice volume. Okay. Next question, y equals 2 minus x squared, y equals 1, and we're going to revolve around the line y equals 1. Okay, so we've got to sketch it out. 2 minus x squared is just a parabola upside down, shifted up 2. Y equals 1. Okay. Now clearly I want the area between those two. And I'm going to draw my slice in perpendicular to the axis of rotation, which is y equals 1. Okay, so it's in there perpendicular. And a quick check, is this function always on the top? Is this function always on the bottom? And I would say yes to both of those. Now, at the moment, I don't know my bounds, so I'm going to quickly set those equal to see where they intersect. 2 minus x squared equals 1. X squared equals 1. Therefore, x equals, remember when you take a square root, plus and minus 1. So I know this is negative 1, 1, and 1, 1. Alright, now I'm going to set up two different integrals to find the volume and see if you agree with this. And again, one is useful and, it could make your math a lot quicker here. So let's say my first setup, I'm going to say my volume is the integral from negative 1 to 1, which I think you'd agree with, and it's pi r squared dx. So volume equals pi, the integral from negative 1 to 1. My radius, I have it drawn in here. Let's put an r there. Upper minus lower, be careful this time. My upper is 2 minus x squared minus my lower, which is 1, and it's all of that junk squared, dx. Okay, so be real careful once you've got your upper minus lower, it's that quantity squared. Now, I've got maybe a quicker method for you. Think about this. Could you write maybe just one integral and double it? Do you notice that this side is symmetric to this side? And I think it'll make your math a lot nicer because it's always nicer to plug in a 0 than it is another number, whether it's positive or negative. 0, hopefully, is one of your favorite numbers this year. So I'm going to say I could go that method, or I'm going to set up a separate integral, which is obviously equivalent. I'm going to say volume is 2, and if I go instead from 0 to 1 of pi r squared dx. Alright, so basically I'm just going to find this area once, or volume once, and double it. So I'm going to say that's 2 pi, 0 to 1, and my radius isn't changing. My upper is still 2 minus x squared minus 1, and it's that quantity squared dx. Alright, so let's just take our time. I think this one's a little nicer. So I've got 2 pi, 0 to 1. If I clean this up inside, I actually have 1 minus x squared dx. Of course, this function minus 1 gets me 1 minus x squared. I'm going to FOIL that out instead of doing a u sub. So I've got 1 minus 2x squared plus x to the 4th dx. And then I'll just quickly integrate from there. Don't forget this 2 pi out front. I've got x minus 2x cubed over 3. So x to the 5th over 5. And again, if I'm going too fast for you, just slow it down and go from on your own pace here. And again, the reason I think this is so much nicer is because when I plug 0 in for my lower, it's going to kill all of this out. Whereas if I had plugged a negative 1 from the previous one, it would be a lot more math. So anytime something's symmetric, that's fair game, of course. So I've got 1 minus 2/3 plus 1/5, and then minus 0. So if I get a common denominator of 15, I'm multiplying this by 15, 5, and 3, which 15 minus, 10 is 5, plus 3, 8/15 for a total of 16 pi over 15. All right, well, I've got one last one for you here. Y equals negative x plus 1 on the closed interval 0 to 1. Okay, so again, a quick sketch is a definite absolute. This is just a linear function shifted up 1 with a negative slope. And I'm going from 0 to 1, which happens to be this section here. So I should probably tell you we are going to revolve this around the x-axis. All right, so go ahead and mark that on your paper, and again, you are perpendicular to the axis of rotation. Therefore, I am a vertical slice. This slice, again, is your radius, so I'm going to put an R there to remind myself that slice I draw on is the radius. All right, I'm going to do two setups. If I wanted strictly area, I'm saying in my head upper minus lower. So the area would be from 0 to 1. My upper function is negative x plus 1 minus my lower function, which of course is sitting on 0, so I don't really need to put that in dx. Okay, so if I just wanted area, I'm upper minus lower. However, if I want volume, okay, on my paper I'm saying volume is the integral of pi r squared. Say it over and over. Volume is the integral of pi r squared. So I'm going to pull out my pi, integrate from 0 to 1, okay, upper minus lower, so I know that's negative x plus 1, and I know I'm subtracting 0, I'm not going to put that in, but it's that quantity squared dx. And again, I would clean that up before I integrate, so I don't need to do a u sub. That'll get me x squared minus 2x plus 1 dx. And then I would just integrate from there, plug my bounds in. Well, hopefully you've got a nice feeling for volume. And again, I'll have some more great 3D pictures to show you, so it makes it a little clearer for you tomorrow in class. Have a great night.